Hello once again. This is Jeff Scott of Rankin Technical College, and I've been going over the PowerPoint presentations for Murock's Android Programming, second edition by Joel Murock for the AWD1112 or 1112 Java programming class. And we're in the middle of chapter 13 of 18, and we're talking about how to add public methods to a database class. Public methods provide a way for the rest of the app to work with a database. Since they're public, it can be used by everything. The first method here that you can see is named getTasks. It retrieves multiple tasks from the table. The declaration indicates that the method accepts the name of a list as a parameter, and it returns an array of task objects. Within this method, first we define a string that specifies the rows to retrieve that are right here. The question mark that you see in here, that's a placeholder. It identifies a parameter that can be supplied at runtime. The next statement, that's defined in the class, it's defined to return a list object that corresponds with a specified list name. Next, we've got an array of strings that contains the arguments for the where clause. This is followed by the use of one of the private methods defined earlier to open up our read-only connection. Next, we use a query method, as you can see right here, to return a cursor object that returns the rows that are retrieved, and this code specifies null values for other arguments. Some of the methods for this cursor class include move to first, to move to the first row in a table, move to next, to move to the next one, and close to close the cursor. Following this, we declare an array of task objects. Finally, we use a while loop to move through all of the rows in the cursor. After the while loop, the last statement will clean up the resources, basically, that are in there. Now this is going to retrieve multiple tasks. Sometimes you don't want that. You only want to retrieve just a single task. So the second method that's shown here in figure 13.9 on page 419 shows how to code the getTask singular method. It works similar to getTasks, but it only retrieves a single row. The declaration indicates that it returns a task object with the specified ID. The first two statements that you can see in there define the condition in the where clause and its corresponding arguments. After you define the where clause, the method opens a read-only connection because that's all we're trying to do is retrieve data, get data. And it uses the query method to retrieve a cursor for a single record. Then it uses the move to first method to move the cursor to the first and only row that's in there. Next, it uses the getTask from cursor method to get the task object from the row. Finally, it closes the cursor in the database connection. So the figure that's here and the figure that's on the next page next we have to talk about how to get data from the cursor. And there's getTask from cursor. Again, this is shown on page 419. It accepts a cursor object and returns a task object. Think about what it's doing. Basically, what we've done is we've just retrieved the current task, and now we're making it available. So it's as though, when we're on slide 28, it's as though we've got this list and we just clicked on Get Haircut. So this is what's going to happen. And that's exactly what the author's saying here. Again, not to be funny, but it's not rocket science. So you can use methods of a SQL-like database object to insert or update rows. Okay. delete would work in a similar way. So this is how we insert a task in. All right, update a task, and delete a task. Okay, it pretty much works the way that you'd imagine. So when you insert a task, you've got to find the one, you've got to fill up what you want to put into the task, all right, and then you write it out. Now, there is nothing in here that's checking. So, for instance, one of the tasks that were in there was get a haircut. There's absolutely nothing that stops you from putting that get a haircut task in multiple times. Each one of them would have its own task ID, but you could potentially do it. All right, so once you've put in all of your code, then it's time to test the database. All right, so once you write the database class, you need to test it to make sure it works correctly. So you can write code that creates an object from the database class. Then you call the public methods from the object to make sure they work correctly. As you test and modify the database class, you may want to delete the database files from the device or use something like DB Browser, which we'll get to in just a moment, for DB Browser for SQLite to view the database. So what they start to show in the figure here, and this is on page 425, is how to test the task list DB database. You add the code, and then you can run an activity to display the results on the user interface, or if you prefer, you can display messages in Logcat view. The code that's shown here begins by creating a task list DB object that's going to be named DB. It also creates a string builder object named SB. That's what you see at the top here. The SB object is used to build a string that's displayed on the user interface. The code that's in here first tests the insert task method by creating a brand new task. Then when it gets done, it calls the update method to update that one. And finally, it's going to come in and call the delete to get rid of it. So to test the database class, you can write code that creates an instance of the database class and use its public methods. If you make changes to the structure of the database, again, you can always increment the version number. And you might do that because as you test the database, you might decide that you need to change its structure. Maybe you need to add another field or combine fields or remove a field. If you want to do that, if you want to basically make a change like that, then what you're going to have to do is modify the code in the onUpgrade method. To get Android to execute this method, you need to increment the version number for the database. Then the next time you run the app, Android will automatically call the onUpgrade method of the helper class and upgrade the database accordingly. If you don't want to continue to increment the version number, you can delete all the data from the app for your test devices and rerun it. But keep in mind that deletes all other data for the app, including any shared preferences. As you test the database, you may want to view the database file that's created on a device. To do that, you can use the standalone Android device monitor tool that's shown on the screen here and also in figure 1313 on page 427. This will allow you to select an emulator or a physical device that has been set up. If you want to copy the database file from the device to your computer, you can select the pull a file option that's here. If you want to copy a file from the computer to the device, you can select or click the push a file option. So to view the file for the database, you start Android Studio, you open the standalone Android device monitor tool by selecting Tools, Android Device Monitor. In the device's view, you select the device. In the main window, you click on the File Explorer tab, and then you navigate to the database's directory for the app. Finally, the last thing that's discussed in here on pages 428 and 429 in figure 1314 show you how to install and use an app known as DB Browser for SQLite. This can make it easier to test SQL statements in your app. If you want to work with an existing database that's on a device or an emulator, you need to start by pulling the file from the device or emulator onto the computer as described previously. Then you can use the Open Database button to open that database. Afterwards, you can check it. So the author mentions on 429, you can use a tool like the DB Browser for SQLite to work with a database that's on the computer, not on a device or an emulator. To install the DB Browser for SQLite, you can search the internet. Just literally type in DB Browser for SQLite download, and there'll probably be some kind of a link in there to do that. To create a new database, you click the New Database button in the toolbar, and you basically go through the dialog boxes. To open an existing database, you click the Open Database button in the toolbar, and again, respond to the dialog boxes. To view the structure of the database, you use the Database Structure tab. To view or edit table data, you use the Browse Data tab. To execute SQL statements, you use the Execute SQL command. Now this, in many ways, this particular chapter was meant to be a review of database functionality and kind of a primer to get you started with SQLite database. One issue you might want to consider is, do you want to store your data on a mobile app in the cloud? If you do that, all right, you can have multiple devices that can share it, for example. And in this chapter, we learn how to use SQLite and work with an SQLite database, but we haven't yet learned how to display the data on a user interface. That's the subject of chapter 14, which starts on page 435, which we will be getting to shortly. But what I thought of doing first, this is old, that's from chapter 12, so let's close the project. And under Book Apps, we want to find the chapter 13. There's the database file, but we want the task list program. Not sure if we have to do anything or if this will run as it is, but we'll try it. Gradle project sync failed. Well, I'm going to have to do a much better job than I'm doing right now of going through this stuff, taking a look at it, and actually as we run through this, seeing why this stuff won't run. It says failed to find target Android 23. Install missing platforms and sync projects. So I'm going to have to go back, rerun all these, and get that stuff fixed. Sorry about that. So that's it for chapter 13. In just a moment, we will start up chapter 14, which, as mentioned, was how to work with tabs and custom adapters. I'll be back with those lectures shortly.